Hello everyone. My name is Qinghua Lu. I'm a researcher from CSIRO Data Sys One. So today I just want to introduce our work on responsible AI engineering and especially how what we have done for agent engineering from system perspective, how to ensure responsible AI safety. Um, Before I start, just a quick introduction on my organization and the team. So CSIRO is Australia's national science agency, and it was formed in 1916. And now we have around 5,000 people, I think, based across 50 sites. Data61 is one of the 9 research units in CSIRO. We focus on data and digital science and technology. And our responsible AI team is quite a young team in CSIRO. We formed this team in 2022, the end of 2021, I remember. But we grow very fast. Now we have around 30 full-time researchers, engineers contributing to this topic. And the 6 researchers in our team are ranked in the top 30 for responsible AI according to their Google Scholar citations. And also I put 2 book covers here. I just try to promote our new books. The first one is Responsible AI. It was published last year, end of last year, and mainly talking about guidelines, best practices for creating a responsible AI systems. And we just finished the second book talking about the key quality attributes for AI systems, how to build AI system to address these qualities from architecture and DevOps perspective. So first slides I put here is just a definition about AI system. The reason I put the definition is I highlight two words: implicit objectives and content. I think in there in the new version of this definition, so you can see we realize the agent, in addition to like waiting for humans instructions or humans goals, humans objectives, they can also infer the next step goals for humans. And also the content is here to reflect the concept of generative AI. And the AI definition is quite simple, just a research of and the development of mechanisms and applications of AI system. And because our event theme is AIware, so I also put definition about AIware here. Actually, in the last chapter of our new book, we also talk about AI as software, AIware, what is AIware. So we try to define it as like an AI system where most of the functions, they can be encapsulated within single general AI model as parameters or ways, rather than like different narrow models they connected together by like traditional business code logic. So there's a trend from small model, narrow model from to a large model, then to the end-to-end AI system or AIware. So for the end-to-end AI, I think the ideal case is like the example Tesla had. So just data in this decision out. There will be no code at all for the future AIware. In the diagram here, we also compare like the difference between traditional AI systems and the current system of near future systems. So on the left side, you can see the narrow model-based systems. We still have some like software code, non-AI code in the system, like the glue code here, or control safety components. Then moving to the large language model or foundation model based systems, the non-AI part will become very thin in the system. So most of the logic will be embedded into the model. But I think we still, at least for the current stage, we still have many some logic outside the model, like the guardrails. We want to understand what we have done, the human have done to protect the AI system, and also if you think about augmented retrieval, systems. So there's like external knowledge base and also some logics to generate to retrieve the data to generate the response for the users of the system. So that's the evolution process for the AI system type. Then talking about responsible AI and AI safety, think back in 2021, 2022, when we work on responsible AI, there were many discussions about whether to focus on AI models or systems, and if it's only about development or also include using AI systems. And then we also talk about, I remember, like not only negative risk, but also should provide benefits to humans. So then based on the discussion, we give a definition about responsible AI. Also is in our book, we give this definition. So it's a practice of developing and using AI system in a way that provides benefits to humans, but also minimizing the risk of negative consequence. And to implement responsible AI, there have been, I think, as a first step, many principles like transparency, contestability to different countries or organizations. They have published different versions of principles. And I think the advantage of those principles is maybe it's quite easy for audience or AI ecosystem stakeholders to understand what responsible is. But then the weakness is like they are very high level and still far away from like concrete practice or concrete guidelines for AI stakeholders. And that's also the motivation for our responsible AI work. And after the principles, we have also seen some standards like NIST standard, ISO standard, EU AI Act finally released this year. And these days there are many mappings from the standards, the laws to the best practice. And for our work, we have also mapped these standards to our question bank and patent catalog. And for last November, in the UK, they organized the first AI safety summit. I think that this is maybe the first time people started using AI safety, like try to maybe replace responsible AI. But at that time, we feel like responsible AI and AI safety, they could be interchangeable. But then more discussions about AI Safety Institute and what can be done as a first step. So more discussions about technical methods like AI evaluation methods, model evaluations, or red teaming, field testing, etc. So we feel like AI safety is becoming like a part of responsible AI, focusing more on like product-oriented technical methods. But responsible AI is like broader. If you look at this slide, when we propose our responsible AI and engineering approach, we thought maybe there could be three perspectives, like from governance, development process, and system perspective, what we can do, the work stakeholders can do, like set up the different level of governance mechanisms, industry level, organization level, or team level. Then development process, different stages, what kind of tools or best practice we can use. Then system perspective, whether to define reference architecture or summarize design patterns or some system level techniques to address privacy security issues. But coming to AI safety, maybe we are more like these days working on how to test the AI system, how to test the agents, how to evaluate the architecture of the agents, how to build runtime guardrails. So I would say at least for our team, our focus is moving to the product part or the system part. And just a bit recall on our responsible AI work. So we started from a question bank. So the question bank, we didn't create any questions from scratch. We collected those questions from different like existing responsible AI risk assessment frameworks. So I think the current version includes around 300 questions. The structure is based on Australia's AI ethics principles. For example, for here on the right side, you can see on the for transparency, explainability, we have some categories and subcategories to further classify the questions. Then we have a different level for each question, and we also map the question to stages of the engineering life cycle. And the last column on this table on the right side is the source, like whether this question was extracted from EU AI Act or from NIST standard. So in this way, people can easily extract the relevant questions. So if they only want to understand what the requirements from EU AI Act, they just select the EU AI Act. So all the relevant questions will be selected. Then to answer the questions, I think our work emphasizes concrete measurement of risk. So that's the motivation for us to work on technical tools and metrics. And our metrics catalog, I think we also like borrowed idea from software engineering metrics. We have process metrics, product metrics, and tool metrics, resource metrics. So what kind of tools can be used in the process? We call them resource metrics, and the output from the process is product metrics. Then to assess the quality of the process, we have an additional layer called key consideration. So to assess, for example, is there a risk committee in the organization? So it's a very high level process metrics, but we can further ask like whether the board members of the committee members, they have the technical background or responsible AI background. So that's the idea of key consideration factors here. Then for the risk management life cycle, so we started from risk assessment and we moved to the mitigation. So mitigation here is we use a pattern-oriented approach. So in software engineering, design pattern is a reusable design solution to a recurring problem in a given context. But here we call all the best practice patterns. I think we just try to use a more rigorous or structured template to describe the pattern, to describe the best practice. And I think that the patterns we have collected still from three levels, the governance process and the product. So for the product, you can see on the right side, we build a responsible AI by design architecture. So all the design patterns are embedded in this architecture. So we say this can become also like a unique feature of the AI product. I mean the responsible AI feature, and because I think for our initial projects, usually we want to like engage with internal AI project teams or external potential customers. But I think there were some barriers for us to do the investigation. So we try to find out why people need to accept or need to work on responsible AI. So that might be a motivation for them to collaborate with us. So that's one of the motivation for us to propose this architecture. And this is just one example about the pattern catalog. So you see that the template we first is similar to the traditional design pattern template, starting from context, then explain the problem, the solution details, then discuss the benefits, drawbacks, what are the existing applications that have already used this design pattern. And as I mentioned, we have mapped the design patterns and also the questions to existing standards. So we are now adding a new field after the known uses, like the mapping to the standards. Like for example, this pattern could be like relevant to ISO standard, some article item. So then the SME companies, they know this pattern can be used to address to meet the standard or regulatory requirements. And we, after the conceptual frameworks, we last year we developed a chatbot prototype. So the stakeholder, they can use this chatbot to understand their organization's AI application risk. And the backend knowledge bases include a question bank, the pattern catalog, and also the incident database. So the first step for this conversation process actually is about matching the AI application to the historical instance based on some features, for example, technologies used or the use case context. So after we match with the historical instance, we can identify the relevant principles. Then we can extract all the relevant questions for this case. Then based on the chatbot and also other agent projects, we think we started working on agent system architecture or foundation model-based system architecture. For agents, we have summarized some unique characteristics. The first one is a complex architecture. So it's like other foundation model systems. So the agent is not just about foundation model. It includes other non-AI components or other components like the gutters I mentioned, the data retrieval components, or the external tools. So the agent, they can decide which tool they call at runtime. Then the second one is autonomy. So the humans, they only need to give the agent very high level goals. Then the agent, they can decide what kind of tools or what kind of data they want to retrieve to to achieve the goal. So in this way, I think more unintended consequences will be introduced by the agent. Then the next one is non-deterministic behavior. So we have seen many articles discussing, like even for the same input, the agent can still generate a different output. So this could be a risk or at least a quality attribute we should consider for reliability. Then the next one is the agents, they need to be, or they are expected to be continuous evoluting. So based on the memory, they can continuous learning, improving their capabilities or some use skills. So these characteristics are all can be, I think, at least to some degree, can be addressed using architectural solutions or architectural approaches. And that's the motivation for us to continue the work on architecture. And our first step was like defining the template for architecture design. So I think last year, around November, there have been already many papers discussing about agent design, like the tool use or rack system. So we try to identify the key components or reusable solution for the architecture. The left side diagram is like showing the ecosystem architecture. So there could be two different types of agents. One is coordinator agent, one is worker agent. So for coordinator agent, the user sends the goals to this coordinator agent, then it do the reasoning, and it can also do the planning, then select what kind of agents, worker agents can help the coordinator agent to complete the workflow. The worker agent, they can use external tool or leverage external tools to augment the capabilities of large language model to complete the task. Then the right side is more a detailed design. So different layers of the agent, interaction engineering layer at the top. We emphasize in addition to waiting for humans' instructions, there can be also a proactive way to describe or create the goals. So based on the context information, like the past interaction between humans and computers, or the document annotation, the browser history. So they can be all used as context for the agent to suggest to the humans. Then we usually people use the prompt template to optimize the prompt to make a large language model easier to understand the original goals from the humans. Then next step is to make the reasoning, make the planning for the to achieve this goal. Then review the plan. So the humans and or the agent itself or other agent, they can provide the feedback to this plan or to the reasoning process. And also they can provide feedback or evaluation results to the workflow execution process, including the intermediate results and also the final results. So this type of feedback or evaluation result, it can be included or stored in the long memory. So as a previous experience or observations, then next time they can be used to improve the agent's reaction to the human's goals. And from this slide, we highlight some boxes as design patterns, the gray boxes. So we also set up a design pattern catalog for agent architecture. So the template is still similar. We use context problem solution to describe the basic solution details, then analyze disadvantage of this solution, like the additional risk introduced by this design pattern. And we also list some like existing agent prototype which have adopted this pattern. And this is a latest work of our team. So because in the old days, we often use ATAM to evaluate the architecture of software systems. But because the unique characteristics we identified, I think our idea was to extend the traditional method to address new features of agents. For example, in this evaluation process, we introduce as the first step to understand the human agent goals or the agent scope, then understand the governance need. For example, in Australia AI safety standard, what are the protocols, which protocols are relevant to this agent based on its scope. Then we identify the qualities, the guardrail requirements, and next step is to define the context scenarios. Because the reason we call them context scenarios, the concrete scenario or the general the scenarios, they can be drive by the agent itself. So it's hard to predict all the scenarios before we deploy the agent. So we can only identify some high-level context scenarios here. Then we also include runtime evaluation, like how to do the continuous monitoring and assessment, and how to prioritize the context scenarios. Then we do the analysis, understand the trade-offs between different qualities and what could be the new risk or risk in this architecture. So we also developed the agent-specific general scenarios for different qualities. The qualities we selected, I think we cover all the AI ethics principles, relevant qualities, and also some key qualities for the architecture design. For example, you can see on this slide, it has performed accuracy general scenario, also adaptability. One difference is, I think in the traditional scenario-based evaluation, the source is usually just a user, but here, in addition to user and agent, we also have like artifact For example, we can have like a runtime evaluator as a source to create the stimulus. For the privacy, you can see there could be also like a tool or knowledge base. They are the artifacts which introduce the privacy stimulus. Then we have the environment response here to we have the response here to, like usually can be architecture approaches to address the stimulus. Then we have the measures for the response, like response time or degree of sensitive data protected. So they can be used in the evaluation process. And for guardrails, we think the guardrails, it can be multi-layers. So I think first we work on the taxonomy, try to characterize the guardrails. You can see this taxonomy includes three groups. The first one is we call them motivation. So they are like external metrics for guardrails. Why we adopt those guardrails, whether it's for protect the privacy or security or protect IP. Then the next group is we call them quality attributes. They are actually internal metrics, internal quality attributes, which qualities are important. So usually when we read the paper about guardrails, they talk about like before using or not using guardrails versus using guardrails. So what's the difference in terms of accuracy or effectiveness? But here we also listed other quality attributes like customizability or interpretability.
Sorry for interrupting, but there's only 5 minutes more and we have to have the panel. Would you mind wrapping up?
Yeah, sure.
Thank you.
Thanks. So then for the design, we have different guardrail actions, like block some prompt or filter some sensitive information or fall back to the previous state. Then tactics, they are more like artifacts of the AI system. So it's in our work, we always emphasize it's not just about user prompt or output from the large language model. It could be also external tools, like they could introduce the quality issues like vulnerability, or the external knowledge base. They could include privacy data, private data, or PII data, sensitive data. So they could be also considered when we design the guardrails. Then the guardrail rules, they could be like designed with priority. So some rules could have higher priority than the others, and some rules, they could be negotiable. We call them soft rules. So that's the guardrail taxonomy. And here just want to show the guardrail architecture. So we want to have like different layers, as I said, not only a context engine layer, like validating the goals, or prompt layer, checking the prompt if they have like some injection problem or privacy problem. For the reasoning planning stage, we could introduce external verifier, like to specify the workflows formally as the external verifier or workflow execution, what kind of exceptions could happen at the runtime. So then we can have exception handling. And we could have like a cross-cutting agent ops layer to support continuous monitoring, evaluation. So that's the idea for this switches model concept. And the last slide I have is just a screenshot about our agent platform. So we have the chat Copilot to allow users to communicate their requirements. Then we have the form on the left side to structure the prompt to include like the guardrails, the persona. Then the user, they can check the interpretation if it's correct or not. Then we have like a visualization of the workflows. Then the user, they can adjust the order of the workflow task, and also add or modify the task in the workflow. And this is we more working on runtime part, like I mentioned, how to use memory or runtime evaluator to improve the agent's skills or capabilities. Yeah, that's all for my talk. Thanks.
Thanks a lot. Thanks a lot, Qinghua. It was a very insightful talk.